So this is something that came up as part of the files solution that Jitendra was talking about earlier. Earlier we were not using compression, so we had not enabled ZFS compression, because for us the compression was done at the back end on the Nutanix AOS platform. But then at some point we figured that it might be better for us to enable compression in files rather than doing it on the back end for various reasons. So as part of that work, one of the requirements that came up was the quotas need to be on the actual size and not on the compressed size. So if we look at the current the default implementation that we have on ZFS, the quotas are applied on the compressed size. So if compression is enabled, the quotas are applied on the actual blocks that are written to disk and not prior to the compression. So that was the thing that came in as a requirement, and we were trying to figure out how to implement that. So before we jump into the actual implementation or the changes that we made, let's take a look at what the default ZFS has in it. So each D node keeps track of the blocks consumed by that D node in DN used. So if you look at the D node fizz, it's essentially keeping track in DN used. And also in the block pointer, we have all the sizes. We have the logical size, we have the physical size, and A size, which is the allocated size on the disk. So the block pointer is fairly neat because we have everything that's needed there. Whereas at the D node, we don't necessarily have the logical size on it. What we have is the physical consumption on disk. So that was one shortcoming that we have to achieve what we wanted for the logical quota. The other thing that if we look at the user and group consumptions, those are maintained in the special D nodes that we have, which is -1 and -2, where we keep track of the blocks consumed by each user. It's an indexed access. It's essentially a ZAP where we index based on the UIDs and GIDs. Not exactly them, but yeah, sort of that gives you an idea of what's happening there. So and for the dataset consumption, I think we are fairly covered, because at the dataset level we keep track of both the compressed and uncompressed count, and we in fact use this for ZFS uses this for the compressor ratio computation. And the space calculation itself is updated as part of the THA sync done by these two routines, which is dnode did use space and do user quota cache flush. So these are the routines which are responsible for doing the updates in there. So that's some background on what we did, or rather what's present in there. And moving on to what we modified. So the changes that we needed were one, like we saw earlier, the D node, we need some field to keep track of what its logical size is. And we also needed to keep track of the logical consumption for the UIDs and GIDs. So those are the two changes that we needed. So for the D node, what we chose was the DNPAT3 in D node fizz. So we picked that field to maintain the logical size. So we call it DNL used instead of as in drawing parallels from DN used, we call it DNL used, which is the logical used of that D node. So that's a new field that we added in there. And for the user and groups, so the user and group was essentially one value that we maintained earlier, right? It was just one value which told us how many blocks or how many bytes each of those users consumed. So I extended that the value field and added a second value in there, which is another 64-bit value, which sort of keeps track of the logical use. So that's an additional field that we added to the ZAP. Now this there's a good chance that that the ZAP, which could have been a micro ZAP if the number of users is limited, definitely switches to fat ZAP in this case. But for all practical reasons, or for all practical users, you may not really have a micro ZAP there if in a real world case. So the number of users could be much larger, and hence it would already be a fat ZAP. So this was not a problem. Couple of reasons why. So that was one of the reasons why we decided to go down this path. The other option that we were looking at is probably use a different D node to keep track of the logical consumptions, but decided to go with the existing one, which is simpler and fairly less amount of change. So what we did in addition to these two things is added a dataset property, which is just a binary switch, flip on or flip off, so called logical quota. So if you say logical quota is on, all the enforcement code, which is when you're trying to do a DMUTX assign, that's the one where you check against the quotas. It would start using the logical quotas. Whereas if logical quota is off, it falls back to the current implementation that we have, which is you apply it on the physical block allocations. So those were the changes that we did, and couple of other things that we modified is in the VFS or in the VNOps, where the backend for stat, which is your ZFS get actor, there depending on the dataset value for logical quota, we switch to reporting the L used instead of the DN used. That was one change, and then the other change is in the ZFS user space, where it reports both the used and the L used in there. I made a small change in ZDB so that it reports both the sizes, which is the L used of the D node. So those are the changes that we made. And so some challenges we had was we were not able to convert the existing or start supporting the compression on the reason I bring in compression. Of course, ZFS does support enabling or disabling compression, but for our purpose, the logical quota, we were not able to enable it on the fly for existing data sets. So we switched to using it only on new data sets. So that was one change, or rather that was a challenge. There's a couple of other things wherein we had an interesting issue where our record sizes, or sorry, the sector size that we support was 4K. And if you had a smaller block, which is like 512 bytes, you'd just allocate, you'd still end up allocating a 4K sector for it. So had to fix that problem, because if you just went with the L size for all the computation, things go wonky when you have a large number of small files. So we had to make that wherein it's actually a max of L size and A size. So if you well, yeah, that's a fix, and I'm yet to bring that into the port. So at what stage is this work right now? We I haven't integrated this with the project quotas yet. I'm still working on that one, trying to figure out how this should integrate with that. The changes have put it out on the link there, so you can go take a look at it. I'll be working on it for some time to make sure it integrates with the project quota. So I'll get that sorted out.
I think this is really cool. You know, I did all the quota stuff way back in the day, and it's cool to see that it extended. One question that I had was what your plans are, or if you have plans to change the way that the, you know, right now you're talking about a logical quota that controls the behavior of all the other quotas versus, I think we had talked offline about the possibility of keeping the behavior of the current quotas and adding new quotas that are like, you know, logical equals 1 gig, logical ref used equals whatever, logical user used equals whatever. I was curious if you had thoughts on how doable that is, and if
it is. Yeah. It's sorry. Yeah. Thanks for bringing that up, Matt, from the offline discussion. Yeah, I missed that one. Yeah, but yes, it's definitely doable because the way I would look at it for the general consumption is that this brings in an additional field in the D node, and now you have pretty much all the control because your block pointers tell us what the logical size is. Now the D node also tells you what the logical size is. And at the same point, for every user and group, we can now keep track of the logical consumption. So once those fundamental counts are available, we could easily build up logical quotas on top of it as individual properties. So it's definitely possible in there. Today, for our use case, it was we just wanted a simple switch to flip it, whereas it can easily be extended to have additional quotas applied. So it's doable. Yeah.
Cool. Thanks. Alan, did you want to ask your question live?
Sure. I actually had a different question. Do you ever run into problems with users having quotas, and if they're very near the quota, the performance is really bad, like write performance?
Yes, we do see that. In fact, it's a little tricky with our cases where if you draw a correlation to what Jitendra was saying earlier about distributed shares, so we have slightly more odd problems in there because the distributed share itself is actually scattered across data sets, right? So assimilating them sort of becomes a problem, and there are quota overruns that we see. But with respect to the usage, yes, we do see it dropping. So because every time you try to do a DMUTX assign, it sort of sees that you're close to it, and since we overestimate as part of the assign,
the overestimate, the inflation ratio is 24x the logical size, which is probably too much. Yeah, so I'll have a candidate patch that will improve that.
I saw that. Yeah. I think that makes sense.
But I was definitely interested in other people running into this problem. And I think the easiest way to tell is there's a K-stat under the DMUTX that counts how many times the system stopped assigning because it thought the quota was full. And if that counter keeps going up, then you're definitely running into this problem.
Yeah. I saw your patch on that one. Yeah, it makes sense, actually. In fact, when we are computing, probably I should just bring this in because so the logical size that we are trying to assign, there's a couple of other tricky things that we had to deal with, wherein whom do you charge the metadata or the indirect blocks, and how do we charge them, because those are kept in triplicate. So there's some compromise that we worked on, that we said if it's not a data block, then you don't charge for the duplicates and stuff like that. It's not directly in the context of your question, but yeah, those again, that's when I was looking at the inflated sizes in there, or the inflated estimates. Cool.
Alan, did you want to ask your other question, and then Mark?
Maybe let Mark have his question first, in case there's short on
Okay.
time.
I just had a simple question. You mentioned that logical quotas only worked on new data sets, right? So you could have an environment where you had old and new data sets, where old data sets would have physical quotas and new data sets would have logical quotas. Is that correct?
That's true, Mark. In fact, we went a little further in our use case. I mean, for general purpose, yes, you could still do that. Between each data set, you could turn on logical quotas. The new
Okay, so does that mean
sets,
that your code is able to distinguish and say, all right, I know this data set
yes,
has a logical quota support, so I'll use those fields.
Yes, yes.
Okay.
Because the property that I was talking about is a data set level property, the logical quota property that
So it just
I
checks
referred
that.
to earlier. Yeah, yeah. This one is a data set level, so you can enable it on individual data sets. Yeah.
Cool.
Thank you.
Yeah, and then my second question was about when you added the accounting for how much logical space has been used, does that extend to snapshots? Like currently, there is no L used property on a snapshot, but is there now in your code?
I'm not sure I got the question because the L.
Because the snapshot space used is like, that's how much space is unique to that snapshot, and then the other accounting values are around, like, you know, how much space was written, how much space is written since some old snapshot or whatever, based on the dead lists, which is all kind of different stuff.
Basically, where that unique value, I think it's actually stored in the object as the field unique. When that's calculated, it'd be helpful to calculate the logical size of that data as well, and store that so that you could actually see the logical used on a snapshot instead of only the physical used.
I see. Okay.
And you know, if you're already adding other stuff to the denote, it may make sense to do all of that in one go rather than separate.
Okay. Okay. Yeah, I'll probably have
data set rather than the denote, but
right. Yes. Sorry. I think it's in the dir obj or whatever it's called.
Right.